Hello and Assalamu alaikum. My name is Mazman. Today we are going to discuss about the topic of physics, which is mass and weight. Today we'll learn about the difference between them, the topics, and the apparent weight and real weight as well. So starting with the basic information about both of these. So mass basically means amount of substance in your body. Alright, and if you talk about the weight, so weight is generated by the gravitational pull of Earth to the center of its, right. So these are the two basic things which we need to know before studying the weight and mass. Right. And if you talk about the mass, for example, if you travel from Earth to moon, this is the Earth and this is the moon. If you travel from here to here, will the mass change? No, mass will not be changed because it's amount of matter in your body and it does not change according to your location. But if you talk about the weight, so if you travel from Earth to moon, obviously it will change. Yes, it will change because the gravitational pull on Earth is very different and the gravitational pull on moon is different, so that's the reason it will change. Now before studying the real weight and weight, we need to understand what are these things, real weight and apparent weight. So we need to write here first real weight and apparent weight. All right. So for example, if I have a surface here and on the surface we have an object of 10 kg. All right. And we know that there are two forces which act upon the body. First force is weight to the downwards, and the second force is the normal reaction, which is always upward. All right, means there is a net force. All right, there's a net force. This force will say that real weight. Consider the weight we are considering, which is downward force, is called real weight, and this is called the apparent weight, which is also called um, tension. It is also called tension. All right, so you need to understand that when we talk about the normal reaction, we always consider apparent weight as a force, and if you talk about the downward force, which is weight, so we'll consider that force is as real weight. All right, now before starting the problems, we need to understand the basic formula, basic units of the mass. So basic unit of mass means SI unit of mass is kg, and another unit is of slug. Depends, and its value depends upon the location of you. If you are in moon, if you are on moon or earth, so it depends there. Right, now we have some cases that we need to solve. Case number one, we have first case in which the acceleration is zero. Means acceleration is zero means body is in rest. If acceleration is not equal to zero, then it's in motion. For example, if I have a lift here and there's a body, all right, there's a body and the acceleration is zero. All right, we are talking about the net force. For example, normal reaction and the weight, so it is called net force. So we'll put the formula here. Net force is equal to W minus T. All right, simple formula for that. We know that the net force there is we know the formula of force, which is mg ma, sorry, ma. If you put a instead of g, then it is called ma is equal to W minus T. For example, a is equal to 0 means a will be 0, and if we a multiply by from mass, so that will be 0 means 0 is equal to W upon T. Will this T will move here, so it will become T is equal to W. What does it mean? It means that the normal reaction and the apparent weight and the real weight are the same, right? The upper side and lower side both are the same. The second case we have in which a body is moving upward. For example, I have a lift here and there's a body, and it is moving upward direction. All right, in upward direction. So the net force is equal to T minus W. All right, and if we just take the maintain the equation, so it will become W is equal to T minus F. For example, means it is saying that the apparent weight is greater than is firstly we need to what we say, maintain this equation. So it will be like t is equal to f plus w. All right, means apparent weight is greater than real weight. All right, the third equation we have, third case or equation, the a problem that we have is there's a lift and which is moving downwards. All right, net force is equal to w minus t, and this t will move here, so it will become t is equal to w minus f. So means the apparent weight is less than the real weight. Now we have the fourth and the last problem for this topic, which is of free fall. Means there's a body in the lift and it is free falling. Means free falling means a is equal to g. The acceleration is equal to the gravitational force, means 9.8 meter per second. All right, now for example, this is the formula for net force, which is equal to f is equal to w minus t, and we'll put the formula for that. We know that the force is ma and weight is mg and minus t. Now there is no cancellation, but we can take the common, but we don't want to take that. We know that the a is equal to g, means we'll put the g here instead of a, and it will both cut down. Means 0 is equal to minus t, means the apparent weight is in minus values. So these were the problems for today, and today we learned about the mass, weight and apparent weight and their problems as well. In the next video we'll discuss the next topic, which is weightlessness in satellite. So stay tuned that for that.